board, you can see hydrolysis of butyl chloride. This is butyl chloride. This is butyl chloride carbon. C4, C4 carbon. H9, H2, 5, 6, 7, 8, 9, and 1 C. This is butyl chloride or chlorobutane. This is on alkaline hydrolysis. What happens? Cl is replaced by OH. We are going to learn this reaction. Initially, we have taken 0.1 molar butyl chloride. One conical mass. In one conical flask, we have taken 0.1 molar butyl chloride. The next conical flask again we have taken 0.1 molar butyl chloride. In all the conical flasks, in the beginning, we have taken 0.1 molar in the beginning, in all conical flasks, we have taken 0.1 molar equal volumes of, for example, 20 equal volumes of this butyl chloride. And we ready to add this sodium hydroxide solution into this equal volume, same concentration, same solution. A stopwatch is to be kept ready. Add to all at the same time, and the stopwatch is started. And the stopwatch is started. After 50 seconds, you check this one and find out what is the amount of that alcohol, right? What is the amount of alcohol? You can find out the amount of alcohol, or using that you can find out how much reactant is left over. That is R. How much reactant is left over? This is R naught. The concentration. In these cases, this is to be kept as a reference, right? At 0 degree, at 0 seconds, this 0.1 molar do not add in the first, because this we are keeping as our view. In the beginning, it was 1. Or we don't have to keep this even, because we already know that 0.1 molar added. After 50 seconds, what is remaining in this C4H9Cl? They have given by doing some experiment, they came to know what is the amount remaining here. So after 50 seconds, we are going to touch this conical flask. At that time, let the reaction go on in those conical flasks. We are not touching that. We will be taking this after 100 seconds. This will be taken after 150 seconds. This will be taken after 200 seconds. After 50 seconds, we determine the amount of this percentage. How much it is? 0.09. Some reaction is over. Now reactance 0.1, from 0.1 it has changed to 0.09. So that value is written over here. After 100 seconds, we touch this control class. Now, some of the reactant got reacted to what is remaining here, 0.0820. I have written. After 150 seconds, I touched this one. So till that much time, the reaction was going on. Reaction kept on going. And here, after 150 seconds, this is the value that is 0.0741, and after 200, after 200 seconds, 0.0671, and after 300 seconds, 0.054. Now we have to find out the rate average. How can you find out the rate average? 15 seconds. Average you can find out in different intervals. Rate average is equal to, that is rate average. I'm talking about this first case. Rate average is equal to minus of delta R upon delta T. Minus of delta R upon delta T. So what is minus delta R? Minus delta R is minus of, that is delta R 0.0905 minus 1 molar divided by 50 minus 0. 50 minus 0. So you can calculate it and you will be getting the value as 1.9 into 10 to the power 1.9 into 10 to the power minus 4 moles per liter per second. So I'm going to write this the rate into 10 to the power minus 4 moles per liter per second. Moles per liter per second. So we calculated this. We got the rate here. Now, between this interval, we are going to find out what is the rate, that is rate is equal to minus 0.080 minus 0.0905 upon delta T. What is delta T between these two intervals? That is 100 minus 50. 100 minus 50. And when I calculated this, I have got 1.7 into 10 to the power 1.7 into 10 to the power minus 4 mole per liter per second. Right? Rate is decreasing. Rate of this reaction is not throughout this reaction. Now I will calculate between 100 and 150. 100 and 150. So here, that is 0.0741 minus of 0.0820 divided by, this is 150 minus 100. 150, that is a delta 150 minus 100, that is again 50 only. And I got it as 1.5 into 10 to the power minus 2. When I calculated, I got here 1.5 into 10 to the power 1.5 into 10 to the power minus 2 moles per liter per second. Right? Next, when I calculated for this 150, between 150 and 200, what is the rate? So in this gap, the rate is minus 0.06 minus 0.0671 minus 0.0741 divided by 200 minus 150. So in this gap, I calculated and I got as 1.4 into 10 to the power minus 4 moles per liter per second. Different, you can calculate for that also. As the time passes, if the amount of reactant is decreasing and decreasing and decreasing, accordingly, the average rate is also decreasing. So, what is the rate of the reaction? During this time interval, this is the rate. During that time interval, a lesser rate, and again that time interval, again lesser. Why it is so? Because rate of reaction depends upon the concentration of the reactant. So, a better word we are going to say instantaneous rate. The rate is decreasing. To say that, okay, at this moment, this is the rate of the reaction. To say that, we are going to say another term, that is instantaneous. Instantaneous. Till now, we said in between 200 to 300, yeah, 200 to 250, or in a specific time interval, we said this is the rate. Now we are going to say instantaneous rate. Instantaneous rate, for that, according to the time, you mark the concentration of the reactants on y-axis and time on x-axis. As the time passes, the concentration of the reactant is decreasing. Right? At a particular moment, for example, at 600, okay, at 400, at 400 seconds, what is the rate? So for that, what you have to do to get the instantaneous rate, take this point over here and draw a tangent on that. Construct a right angle triangle. And this y by x. Y by x, that is the instantaneous rate. Y by x will give you the instantaneous rate. So for average rate, we said between 300 to 400 average rate, between 400 to 500 rate average rate. But at 250 seconds, that is rate instantaneous. We show rate instantaneous, that is rate instantaneous. Or at 350 seconds, yeah, at 400 seconds, that is rate instantaneous. So rate instantaneous, how we are getting rate instantaneous? So between 200 and 400, rate average. When that gap decreases, when that gap is decreased, that is delta T tends to 0. Delta T tends to 0. So you can write in this format, that is dx by dt is equal to limit delta T tends to 0, delta x upon delta. You can write like dx by dt equal to limit delta T tends to 0, delta T tends to 0, delta x by delta t. Delta x by delta t, or dr by dt. dr by dt, instantaneous dr by dt. Limit delta t tends to 0, delta r upon delta t. So this is rate instantaneous. So rate average means between the gaps. Rate instantaneous means when the delta t tends to 0. That is rate instantaneous. Next, we are going to see what are the Conditions on which the rate of the reaction depends. What are the factors on which the rate of the reaction depends? Factors on which the rate of the reaction depends. So factors means concentration of the reactants. In case of gaseous reaction, concentration of the reactant means pressure of the reactants. Pressure of the reactants. In case of gases, pressure of the reactants. Then temperature, as you heat test tube, sometimes while doing some reaction, you are heating the test tube. When you heat the test tube, you are actually increasing the temperature. When you increase the temperature, you are making the reaction rate fast. When you add a catalyst, the reaction becomes faster. Positive catalyst makes it faster, negative catalyst makes it slower. For us, mainly positive catalyst. Then surface area. As the surface area increases, the contact between this reactant molecules increases. So the rate of reaction. Reaction means the molecules, atoms collide. According to collision theory, they collide and a product is formed. So as the surface area increases, suppose catalyst surface area, many molecules can make contact with other molecules, or many atoms can make contact with other atoms. So as surface area increases, the reaction rate increases. So what are the factors affecting or influencing the rate of reaction? Number one, concentration of the reactants. Concentration of the factors. Number one, concentration of the. Number two, temperature of the reaction. Temperature. Number three, catalyst. Number four, surface area. This chapter mainly deals with concentration of the reactants. Concentration of the reaction, temperature portion is deleted this year. So we will be learning the concentration of the reactants. Temperature portion is only very less. Mainly 99% of this chapter is based on the concentration of the reactants. So first one we are going to learn the concentration of the. How does the rate change with the concentration of the. Okay, just now we saw as the concentration of the reactants decreases, the rate of the reaction is also decreasing. In what way the concentration of the reactants affect the rate of the reaction or the speed of the reaction? For a typical reaction, A plus B is CC plus D. Last year, in equilibrium chapter, we put an equilibrium sign there. That time we defined is equilibrium constant. Now we are going to define a rate constant, not equilibrium constant. Rate constant, this is also given by K, simply K, not Kc or Ka or Kb. Kc for general, Ka for acid, Kb for base. Right? But here only K, rate constant K. So we say the rate of the reaction is proportional to what all things? The concentration of the reactant A to the power, not A, not the stoichiometric version, some other letter X, something else. and b to the power, not b, but y. X and y, that shows along this A or on this A, how the rate of the reaction is getting affected. Y shows that through B, how the rate of the reaction is getting affected. Sometimes Y is equal to 0, that means the rate of reaction is not at all affected by the change in concentration of B. If X is equal to 0, that means the rate of the reaction is not at all affected by the change in concentration of A. That is also a possibility. So rate of this reaction is equal to a constant K with constant A to the power X and B to the power. So this is the rate of the reaction. The rate is equal to rate constant. The rate and rate constant both are different. Rate, this one. Rate may be average rate, maybe instantaneous rate, or maybe more differential rate, dx by dt, here dr by dt. In the case of reactants, we have to put minus sign, minus dr by dt. Minus dr by dt is equal to k to the power k into k to the power x into the power 1. This is the equation or the expression which shows the rate of the reaction in terms of concentration of the reactants. This expression is called rate expression or rate law or differential rate equation. So the representation of rate of reaction in terms of concentration of the reactants is called rate law. The rate expression, right on. What is rate law? What is rate law? The representation of rate of reaction in terms of the representation of rate of reaction in terms of concentration of reactants. Concentration of reactants is known as rate law. Rate law or rate equation or rate expression. Today's date is 29. No? The representation.
Yes,
okay. The representation of the rate of the reaction in terms of the concentration of reactants. The representation of rate of reaction in terms of the concentration of the reactants is called rate law or rate expression or rate equation. Rate law, L-A-W, rate law, rate equation or rate expression. So that is the X and Y. We say the order of the reaction with respect to A. The order of the reaction with respect to A, that is X. Y, we say order of the reaction with respect to B. Means On B, if you change B, how the rate of the reaction is affected? That is given by that number. If it is 2, that means B square. The rate of the reaction along B, how it is affected? That is what is meant by order of the reaction. Right on. X is the order of the reaction with respect to A. X is the order of the reaction with respect to A. And Y is the order of the reaction with respect to B. Y is the order, O-R-D-E-R, order of the reaction with respect to B. X plus Y, that is called overall order of the reaction. X plus Y, that is called overall order of the reaction. Overall order of the reaction. This X can be fractional, Y can be fractional, X can be 0, Y can be 0, X can be negative, Y can be negative. All possible things are possible. All possible numbers are possible here. X plus Y is the overall order of the reaction. For example, if I give you one reaction, write one reaction, CHCl3 plus Cl2, CHCl3 plus Cl2, CHCl3 chloroform plus Cl2 gives CCl4 plus HCl. Suppose rate is equal to rate constant into CHCl3 to the power CHCl3 to the power 1 and Cl2 to the power half. This is the rate equation, your rate expression. So what is the overall order of the reaction? 1 plus half, that is 1.5, that means 3/2. That is the order of the reaction. Okay, thank you.